All right, let's jump right in. Today we're looking at a real powerhouse tool for anyone doing spatial analysis, an R package called movecost. Now, if you're a scholar in fields like archaeology, geography, or ecology, basically any field that has to deal with how things move across a landscape, this is definitely for you.
You know, it's such a fundamental question for so many researchers, right? How did ancient people actually travel between their settlements? What's the most likely path a wolf is going to take through a mountain range? The simple straight line, as the crow flies, is almost never the right answer. The real world is just way more complex than that.
Okay, so here's our plan. We're going to start by totally reframing how we think about movement. Then, we'll take a quick tour of what movecost can actually do. We'll look at the engine that gives it so much flexibility, see why it's a tool built for serious research, and then, hopefully, get you ready to start your own analysis. So first things first, we have to get away from these overly simplistic models. If we really want to understand how things, whether it's people, animals, or even vehicles, actually move, we've got to think beyond just the shortest distance between point A and point B. And here is the absolute core idea. When we say cost, we are not talking about money. We're talking about the expenditure of resources. It could be time, it could be metabolic energy, it could even be just abstract effort. Think about it. Climbing a really steep hill has a much higher cost than walking on a flat path, even if the distance is exactly the same. This one concept is the heart and soul of movecost. So, let's see how this one core concept builds out into a truly impressive toolkit. This isn't just a single function. It's an entire analytical pipeline, and it's designed to handle a huge range of research questions, all inside this one package. The package gives you a complete workflow. You start by calculating what's called an accumulated cost surface. Think of it like a map, where every single pixel shows the total cost to get to it from your starting point. From there, you can trace the single path of least resistance, or you can define entire corridors of likely movement. You can even build these complex networks connecting multiple sites or compare different what-if scenarios side by side. It's really cool. And this really shows you the power we're talking about. You can go from a foundational analysis of just one landscape all the way up to modeling these intricate networks of interaction between dozens of locations, and you never have to leave the movecost environment. It's totally comprehensive. Okay, now we get to the real engine of this package. This is the feature that gives it its incredible flexibility and makes it so adaptable for all kinds of different research projects. So if everything is based on this idea of cost, the big question is, well, how do you actually calculate it? How do you turn a slope on a digital terrain model into a number that actually represents effort or time? Well, how many ways are there to define cost? The answer is, you get to choose. movecost comes loaded with 26, that's right, 26 different built-in cost functions. And get this, every single one is derived from peer-reviewed academic literature. This isn't guesswork. It is grounded in solid, established research. And the range of options here is just fantastic. Are you modeling human hikers? Well, you can use classic walking time functions like Tobler's. Are you studying ancient trade routes with carts? There's a function for wheeled vehicles. Researching animal foraging behavior? You can model the cost in terms of metabolic energy. You get to choose the function that best fits your specific research question. But the customization doesn't even stop there. You can fine-tune your analysis even further with something called the terrain factor. This basically lets you tell the model that, hey, walking on a paved road is way easier, it has a lower cost, than slogging through a swamp or trudging through loose sand. And for those of you modeling human behavior, it gets even more nuanced. The package actually lets you use something called cognitive slope instead of real slope. This accounts for that well-documented psychological quirk where humans tend to overestimate how steep hills are. It just brings your model one step closer to reality. So we have this incredibly powerful and flexible toolkit. But what gives scholars the confidence to actually use it in their publications? Well, it's the academic rigor that it was built with from the ground up. This isn't just some code that somebody posted online. The package itself is described in a peer-reviewed journal article. And what that means is you can use it in your own work and cite it properly, feeling totally confident in its methodology and its transparent origins. And it is packed with features for serious research. Every single one of those 26 cost functions comes with full bibliographical references, so you know exactly where it came from. It can handle complex, real-world scenarios, like impassable barriers or weirdly shaped coastlines. And of course, it exports all your results into standard GIS formats, like GeoTIFF or Shapefile, so you can use them in other software. Now, are you worried about the learning curve? Don't be. The package comes with what's called a vignette, which is basically a super detailed user guide packed with explanations, background on the methods, and tons of code examples to walk you through your first analysis. It's an incredibly helpful resource.
So ultimately, movecost provides this comprehensive, transparent, and academically rigorous environment to explore that really fundamental question: how and why does movement actually happen across a landscape? By giving you the power to define cost in a way that truly fits your work, this package just opens up so many new avenues for investigation. So whether you're mapping ancient roads, predicting animal migration, or planning hiking trails, the possibilities are just immense. Thanks for watching.